This is the second part of VOCs. In this part I want to talk about control by prevention. So basically we have two types of treatment with VOCs. One of them is to prevent VOC formation and the other one how to treat VOCs. So if it's possible, we prevent the formation of a VOC containing air or gas stream, which we must treat by some kind of control devices. So as you see here, we have three methods. One of them is substitution, the other one is process modification, and the last one is leakage control. So the first process is substitution. So basically we change the process or method by substitution. For example, replacing oil-based coating and inks by solvent-free or water-based coatings, and also replacing gasoline as a motor fuel with compressed natural gas or propane is also a form of substitution that reduces the emission of VOCs. So for the first one, as you remember, we had during 70s or 60s or even earlier than that, we had some coatings that use some kind of solvents, for example xylenes, even toluene, stuff like that. So they were highly volatile solvents. So nowadays all these coatings are replaced by a new generation of coatings like solvent-free or high solids coating or even water-based coatings. As you know, in water-based coatings we have much less solvent usage. And powder coating, we have no solvent at all, so we have zero solvent. In solvent-free or 100% solids coatings, we have zero solvents, so there is no emission of VOCs during the coating drying or coating curing. Also in gasoline, as you know, as a motor fuel, gasoline is replaced by natural gas or propane, and nowadays we have electric cars. So since gasoline are highly volatile, we need to replace it with some other kind of fuel that are not volatile. Another type of this kind of control by prevention is process modification. Process modification to prevent or reduce the formation of a VOC stream may be more economical than applying the control options. For example, replacing gasoline powered vehicles with electric powered vehicles is a form of process modification that reduces the emission of VOCs as well as emission of carbon monoxide and nitrogen oxides in the place the vehicle is. Or we can change the operating conditions of some processes. For example, to change the temperature, pressure, composition of the air and gas. That helps you to increase the efficiency of fuel burning to produce less VOCs while it's burning. And the last topic in prevention of VOC formation is leakage control. So as you know, for example, storage tanks containing liquid VOCs can emit VOC vapors because of filling and emptying activities as well as changes in temperature and atmospheric pressure. These emissions are called filling or displacement losses, emptying losses, and berthing losses, or collectively working losses. So as you know, we have different kind of storage tanks. Some of them are atmospheric, some of them are pressurized. So these kind of tanks, if they contain some volatile liquids during this filling or emptying activities, we lose some of these liquids by vaporization of these liquids. So we have VOC formation during this kind of activities. How to prevent that? we need to lower the temperature, we need to use some light colors as a coating for outside of these storage tanks, or we can use pressurized tanks to store this material. So using this kind of activities we can prevent VOC formation. Another topic in leakage control is displacement and breathing losses for gasoline. As you know, the greatest interest in these types of losses concern gasoline because we use so much of it, about 350 million gallons per day in the United States. Gasoline is a complex mixture, typically containing perhaps over 50 different hydrocarbons in concentration of 0.01% or more, plus some other trace of components. The smallest molecule have 3 carbon atoms, and the largest typically has 11 or 12. So basically, based on the vapor pressure and the molecular weight of all these components, we have different loss rates when we transfer it from one container to another container. So, and also, as I said earlier, because we are dealing with highly volatile components, it's better to use a floating atmospheric tank or pressurized tank. Mostly it uses a floating tank. So these floating roof tanks, they have a roof that is going up and down with the level of liquid in order to minimize the head space. So that prevents from VOC formation. So it prevents evaporation. And the last part is about seal leaks. Many small emission of VOCs occur as leaks at seals. In recent years, these have come under regulatory control because as the larger sources are controlled, these become a more significant part of the remaining problem. Basically, this sealing is very important when one of these two surfaces involved in the seal moves relative to the other one. So in the next topic, I will talk about control by concentration and recovery. So basically, so far in this topic, we had this control by prevention due to substitution, process modification, and also leakage control.